Section 6.1 in intermediate algebra deals with rational expressions. Like a fraction in arithmetic, a rational expression is a ratio of two expressions. The calculations that are performed with rational expressions resemble those performed with fractions in arithmetic. Fractions are simplified by removing a factor equal to 1. And that's what we'll do on this first part of section 6.1 is simplify these fractions. In other words, reduce them. So we're looking for common factors between the numerator and the denominator. 16 over 8, greatest common factor is 8. 8 divided by 8 leaves a 1. 16 divided by 8 leaves a 2. We have common bases of x as well with the greater power in the denominator. So we'll do the subtraction of our exponents because of the division in the denominator to avoid a negative exponent. If we had done 4 minus 5, we would have had x to the negative 1. Instead, we'll leave our x in the denominator. So the x to the 4 actually is canceled out because we're doing the subtraction of exponent down here. Our numerator only has the 2 when we reduced our 16 over 8, and the denominator, x to the 5 minus 4, leaves us with x to the first, or just simply x. In this next problem, when we're reducing, we're looking for common factors that cancel out. Just up, we had in this previous example, we had an 8 over 8, which canceled out, leaving us with a 1 because it was a common factor, something that was multiplied together. So before we cancel, looking vertically up and down, common to the numerator and the denominator, look across to see if we can factor this, because right now the only factor is just the 2x by itself, but because it's being connected with an addition or subtraction, in this case the subtraction, there's nothing that we can do as far as reducing this until we have a product of factors. So in the numerator, common between the two terms is a greatest common factor of 2. 2x divided by 2 leaves an x. Negative 12 divided by 2 leaves a negative 6. We now have a product of two things, a monomial and a binomial, that's equivalent to this original expression. Similarly, we'll factor the denominator. Greatest common factor is a 3. Dividing or factoring by a 3 leaves an x for the first term, and negative 18 divided by 3 leaves a negative 6. Now we'll look in the numerator and the denominator, and if we see a common factor that cancels out, we'll do so. And if we look, 2 and 3 don't have anything common, but we do have a common binomial in the numerator and the denominator, just like an 8 over 8 canceled out to equal 1, an x minus 6 over an x minus 6 cancel one another out, leaving a 1. 1 times 2/3 leaves us with a final answer of 2/3 for the reduction of this rational expression. If you recall from adding and subtracting fractions together, we have to have a common denominator, and this is going to help us when we have a polynomial divided by a monomial, or this rational expression. To simplify it, we're going to use the following concept. When you add fractions or rational numbers together, you have to have a common denominator. Having a common denominator, you then go ahead and add the numerators over that common denominator. Generally, we're going from left to right, adding common denominators or adding fractions together that have common denominators, giving us the final result. But we're looking at an expression that's similar to this right-hand side, and we're going to reverse this direction. Where did this rational expression come from? Each of these terms must have had that common denominator, which in this example is 2. So we're going to pull those apart. Common denominator, you would combine your numerators, and that's what we have, but by pulling them apart, we now can simplify each of these rational terms here. 4m over 2, or 4 divided by 2, is going to leave us with a 2m, because 2 divided by 2 is 1. 4 divided by 2 is 2, and 2 times m leaves us with the 2m over 1, or 2m, minus 6 divided by 2, or divide numerator by 2 leaves a 3, divide the denominator by 2 leaves a 1, and 3 over 1 is a 3. So we've reduced our rational expression by going to the undoing of our common denominator when adding or subtracting fractions or rational expressions. They're asking us to simplify here as well, and again, caution you before looking numerator denominator to cancel terms out, factor instead because you're looking for a common factor. So in the numerator, greatest common factor between those two terms is a 9 for the integers and an x squared, the lowest common power between the two terms. Dividing the first term by 9x squared leaves a 1. 27x to the third divided by 9x squared, 27 divided by 9 is 3. X to the third over x to the second leaves an x. In the denominator, greatest common factor is a 7 in terms of the integers, and an x for the variables is the lowest power common to both of those terms. Factoring is dividing, so 7x divided by 7x leaves a 1. 21x squared divided by 7x leaves a 3x. Now we can look numerator and denominator. What are the common factors to the numerator and the denominator? Canceling out anything common, we have an x plus 3 over an x plus 3, which is 1, the most obvious one. 9 and 7 don't have anything common, but x is our common basis. Subtract our exponents, 2 minus 1, since the higher exponential power is in the numerator, leaves us with an x to the first in the numerator and cancels out the x in the denominator. Final answer then is a 9x over the remaining 7. Always it's a good idea when you factor to be sure you multiply distributively or FOIL method if appropriate to be sure that you have an equivalent expression before you move forward. In this next one, again, we don't have any common factors because these terms are connected with subtraction, so we can't cancel out yet. But if we factor, perhaps we will find a common factor. We're looking for numbers that multiply to give us negative 10 and add up to be a negative 3. We don't have a lot of choices, and the pair that works is an x minus 5 and an x plus 2. In the denominator, we're looking for factors, two binomials that multiply together to give us this trinomial, and we're looking at specifically factor pairs that multiply to give us negative 12 and add up to give us a negative 4. We have several choices, 1 and 12, 2 and 6, 3 and 4. One has to be positive and one has to be negative, and the pair that works is an x plus 2 times an x minus 6. Again, always check your factoring, multiply them back together to be sure that you have an equivalent expression. Now we have factors, something times something in the numerator, likewise in the denominator, that we can look in the numerator and the denominator for a common factor. There is an x plus 2 in the numerator over an x plus 2 in the denominator. That is equivalent to a 1. Anytime you have the same quantity over the same quantity, it reduces to a value of 1, leaving us with an x minus 5 over an x minus 6. That is our final answer. And we have to know when to take the brakes off. You may be thinking, but there's a common x. These are not connected with multiplication, so we have to stop there. Only if we had that similar binomial in the numerator or denominator could we cancel it out. This last example, they're asking us to simplify or reduce this. Again, we start with factoring the numerator. Do not look up and down for common factors yet. We don't have factors. So between the two terms, there is a 4. And just because we normally have positive x's on our factoring in our binomial, let's take out a -4 in anticipation of not leaving a negative x. Instead, factoring out a -4 will cancel out the negatives and leave a positive x. -4 divided by -4 will leave a +1. Distributively, we can see we have what we had. In the denominator, there's definitely a common factor of 2, and if we dig a little deeper, we find there's a common 4. Each of these terms divided by or factoring out a 4 leaves us with a 5x squared, a 7x, and a 2. Right now we have two things multiplied together in the numerator and the denominator with a common factor of 4, so the 4's cancel out, leaving a 1. So we have a -1 times x plus 1 in the numerator. In the denominator we have this trinomial left, which, let's see if we can factor it. 5x squared must have come from a 5x and x. 2, we don't have any choices other than 1 and 2. Both signs are the same. Both are positive. But we have two options of where we put that 2. We can put it here, so we would have a 2x and a 5x, which do add up to be the 7x. Or we could put our 2 here, which would have given us a 10 and a 1, which would not have given us the 7. So a 2 here and the 1. Now looking, again, we have more factors, and we have in the numerator and the denominator an x plus 1 over an x plus 1, which cancels out. So our final answer leaves us with a -1 in the numerator and this binomial 5x plus 2 for the simplified form.